Differential scanning calorimetry. It is difficult to obtain quantitative data from the conventional differential thermal analysis because of the instrumental parameters like specific heat, thermal conductivity of the sample, placement of thermocouples, rate of heating, etc. Quantitative results can, however, be obtained by differential scanning calorimetry. Changes in heat constitute an essential aspect of most chemical processes. The determination of the temperature dependence of enthalpy changes is a fundamental characterization of a chemical process. Calorimetry is a measurement technique which measures the changes in heat of an isolated system. Differential scanning calorimetry is a technique in which an approximately linear temperature profile is imposed on an isolated system while a reaction takes place in one part of the system. Differences in temperature between the sample zone and the reference zone provides information about the thermodynamics of the reaction. The technique can be defined as a thermal method where the energy necessary to establish a zero temperature difference between a substance and reference material is recorded as a function of temperature or time when both the substance and the reference material are heated or cooled at a predetermined rate. Principle and technique of differential scanning calorimetry. Differential scanning calorimetry is a thermoanalytical technique in which the difference in the amount of heat required to increase the temperature of a sample and reference are measured as a function of temperature. Both the sample and reference are maintained at very nearly the same temperature throughout the experiment. The temperature program for a differential scanning calorimetry analysis is designed in such a manner that the sample holder temperature increases linearly as a function of time. The reference should have a well-defined heat capacity over the range of temperatures to be scanned. The basic principle underlying the technique is that when the sample undergoes a physical transformation, such as phase transitions, more or less heat will need to flow to it than the reference to maintain both at the same temperature. Whether more or less heat must flow to the sample depends on whether the process is exothermic or endothermic. For example, as a solid sample melts to a liquid, it will require more heat flowing to the sample to increase its temperature at the same rate as reference. This is due to the absorption of heat by the sample as it undergoes the endothermic phase transition from solid to liquid. Likewise, as the sample undergoes exothermic processes such as crystallization, less heat is required to raise the sample temperature. By observing the difference in heat flow between the sample and reference, differential scanning calorimeters are able to measure the amount of energy absorbed or released during such transitions. Differential scanning calorimetry may also be used to observe more subtle phase changes such as class transitions. Differential scanning calorimetry is widely used in industrial settings as a quality control instrument due to its applicability in evaluating sample purity and for studying polymer curing. In this technique, two sample pans, one each for test and the another for reference material, are provided with their own heating coils and resistance thermometers. The current in the heating coils is regulated by a control unit which heats or cools the sample and the reference at the uniform rate. As the test sample and the reference are heated or cooled, the differential thermocouple starts to register a voltage. The automatic control unit supplies the power to the cooler sample in order to keep both the sample and the reference at equal temperatures. The power that is required to keep the temperatures of the two equal is automatically recorded as a function of the indicated program temperature. The thermogram which is obtained resembles conventional differential thermal analysis thermogram, but the area of the peak corresponds to the amount of energy absorbed by the sample to compensate for the endotherm reaction or released when exothermic reaction takes place.